Today we're going to continue doing rigid transformations. And this is just kind of a warm-up to get you to think about this. So if we're moving from A to B, we'd like to use some translations, some rotations, and possibly reflections as well. From A to B, there are a couple of different ways that you could do this. I'll take a volunteer to give me your steps in doing this one. If I don't get a volunteer, I'll randomly choose somebody. Yes, Christian.
You can flip. You can flip it Y 1.
Wait a minute. Flip what? I'm sorry.
Like A.
Flip it.
Down.
Okay. So
At
what?
one.
So flip it over y equals 1?
Yeah.
Okay. So let's see. Flip over y equals 1. So if we do that, that's 1, 2, 3, 1, 2, 3. And I'm not going to try and draw the key. I'm just going to draw the triangle and the dot. Okay. And then what?
And then you can flip it again at -2.
Flip it over x is -2?
Oh. Wait, no. At x0, I meant.
1, 2, 3. Yeah, if you flip it over, so you have to tell it what line you're flipping it over. So we're flipping it over x equals 0. And that's 1, 2, 3, 4, 5 away. And that's 1, 2, 3, 4, 5. Yep, that lands it perfectly on there. So that's just 2 steps. There are other ways to do it. And in question 2, it asks you to find a different way. I'll take another volunteer who can tell us how they did theirs. Again, if I don't get a volunteer, I'll use my random number generator to voluntold somebody. Wow. I know that you guys have them, but okay. Quit out of that, clear that. Math, probability. I want a random integer from 1 to 12. I only want one of them. And Emma. It came up number 12. So tell me how you did it. It doesn't matter how many steps it is. You didn't get there?
No, because I accidentally did B instead of A starting, so then I had to restart that one.
Well, tell me how you would get from B to A.
Flip by -2 vertical.
Wait a minute. So when you say flip by -2 vertical, do you mean flip it over? I'm not following. You always have to tell it what line we're flipping it over.
-2.
So x is -2? Or y is -2?
Y.
Okay.
I think I did it wrong.
So you just flipped it over this so that it looked like that?
No, Y.
This is y is -2.
Oh, then X.
Because see how it goes through the y-axis at -2?
Oh, yeah, X.
Okay. So if we flip it over, x is -2. See, that's 1, 2, 3 away, so it'll be 1, 2, 3 away over this direction, and it's the mirror image.
Now that I look at it, I should have done it farther over.
That's okay. Then what?
Flipped it again, but where it's on the X1 intersects X equals 1.
X equals 1?
Vertical again.
Wait a minute, x equals 1 is here. You want to flip it again?
Yeah, that way it goes up the way that the A
If you flip it over x equals 1, it's going to look like this.
Y equals 1.
Yeah, y equals 1 would be here. And the problem with flipping it over there is it's going to run right into that wall. Okay. So over -1, and then it would be right there.
And I did, move, I did, the translation,
Mm-hmm.
move it horizontal 4,
Right. And then,
vertical 5.
yeah. Yeah, absolutely. Yeah, that works. All right. Well, I'm going to get one more volunteer for that one. Mr. Johnson,
Mr. Davis.
can you tell me a way to get from the triangle from A to B?
No, wait, we already did that one.
Yes, I know. We're doing this again. I'm getting another way.
Translate it down by 6 on the y-axis.
So let's just say translate down 6.
Yeah.
I think that's easiest for everybody, and everybody knows exactly what you're saying. So 1, 2, 3, 4, 5, 6.
And then
Hang on a second, let me get it drawn. All right, go ahead.
to the left 10.
All right, so translate left 10.
Right, yes.
So that's going to move it to right here.
Yes. And then rotate 180 degrees. It doesn't matter which way.
All right, and you're rotating it 180 degrees about the point. Yeah. Now, when we start doing these without the key there, we'll have, all 3 points. So let's go ahead and just say what the points' coordinates are. They're -5, -2. And we'll start doing that. So, although we haven't talked about it before, one of the things you could have done after you translated it down here is instead of rotating it about the point, which is on the ones we did yesterday, that was the only point they would let you rotate it around, we could have rotated it around, let's see, 1, 2, 3. Oh, what if we just rotated it around the point 0, -2? Then this would have just rotated around over to here in place. All right. Well, let's talk about B. Let's see who's volunteering for this one. Cooper.
Go up 4.
So let's translate up 4. All right. Up 4. So let's see. 1, 2, 3, 4. That would look like this. All right, go on.
And then you can move to the right. Oh my gosh. You can move to the right 6 times.
All right, so translate right 6. So 1, 2, 3, 4, 5, 6. Then what?
You have to go to the right 180. And then you have to, I have to flip it.
Okay, so you're saying rotate it around this point?
Yeah, and then I have to flip it.
So let's rotate 180 degrees about, and we'll name the point. So that's at 4, 0. So now it looks like this. Then what?
And then flip it at y-1.
Yeah, exactly right. Flip over y equals -1. That absolutely works. So this would be your mirror line. That would end up right down here. Oh, let's share the love. Let's see. Who's in desk 7? Ben. All right. Tell us how you did this one.
It's the same as Cooper.
Exactly?
Kid, you can do it. I hadn't even did it. I came up with that on the fly.
I mean, seriously, is it the same or not?
Do it again, then. Come on.
It's just, I don't,
All right. Tell me what you did.
well, it's a little bit different. You go up, you translate up 4,
Okay. Translate up 4.
and then you,
Whoa, 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 whoa. Let me get it drawn. 1, 2, 3, 4. Go on.
translate to, and then translate, x plus 6.
So translate right
Yeah, right
6. 1, 2, 3, 4, 5, 6. So far, this is looking exactly alike.
And then, I reflected it on x equals -4. I mean, x equals 4.
Reflected. Okay. So reflect over x equals 4. So that's right there. So it's going to look like this.
And then translate it down to,
Yeah. Very nice. So it started off the same, but then you did something different at the end. That's good. Yes.
Now can I do?
Yeah, absolutely.
So I flipped out y -2.
All right, so we reflect over y equals -2. All right, so that's here. So that's 2 away, so it's going to be 2 to the other side, and it's going to be the mirror image. All right,
Then I reflected x at 1.
okay, so reflect over x equals 1. All right, so that's 1, 2, 3 away, so it'll be 1, 2, 3 to the other side, and it'll be the mirror image. Yep,
Then I reflected it y -1.
so reflect over y equals -1, which is here. That's kind of cool. You did it with 3 different reflections.
good job.
Okay, these are all great ideas. Okay, anyone else have one that they especially like and want to share with us?
Johnny, did you say you had one, Johnny?
He didn't say that, so why are you saying that?
Because he had told you.
Okay, so now we're going to try following someone else's instructions on transforming a triangle. So let's see if we can follow this. The vertices of the triangle are at -5, 0, -5, 3, and -1, 0. All right, it says translate 4 units to the right and 2 units up. because I can, I'm just going to do a different color every time just for the fun of it. So to the right 4 and up 2. So it should look exactly the same. It's just been translated. It's been slid to a new place. Reflect over the line, y equals -1. So let's do a different color. So we're reflecting it over this line. So that means this point that's 3 spaces away from the reflection line will be 3 spaces away on the other side, just like this one will be. And this point that is 6 spaces away from the reflection line will be 6 spaces to the other side. So that now looks like this. And then finally, rotate counterclockwise 90 degrees about the point 3, -3. Let's see, 3, -3. 1, 2, 3, 1, 2, 3. Oh, now notice this time they're actually asking you to rotate around a point that isn't one of your points. Sometimes the easiest thing for you to help see this, I can't do it on my screen, but is to actually put your pencil on that point and rotate your paper counterclockwise 90 degrees to see what it would look like. So take your paper and rotate it, 90 degrees, and that's what it's going to look like. Okay? So when you rotate that 90 degrees around this point, and be sure you're going counterclockwise, not clockwise, so it's going to be rotating around this direction. Let's see, after that rotates 90 degrees.
This is clockwise.
So does it look like, I'm trying to visualize it without being able to spin my paper. Does it look like this? Oh, sorry, wrong place. Hang on just a second. It's going to look like this. Yes? No? Have a banana, Mr. Davis? So again, if you're having trouble seeing it, let me show you. So I'm going to take that. Hold my paper still and rotate my paper counterclockwise 90 degrees. That's what you should be seeing. So you can see that this top point is now to the right of the point at which I'm rotating it around. I think for most people the rotations are the hardest ones to see. So again, rotate your whole paper to help you see that if you have difficulty with it at all. All right, now compare the triangle that you have after step 3 with the original triangle. How do the lengths of the sides compare? How do the angle measures compare? Well, if I'm looking at those two triangles, here's the original, here's my final. Are the side lengths the same as they were before? This has side lengths of 3 and 4 and something. This has 3 and 4 and that same something, doesn't it? So the lengths of the sides are the same. What about the angles? Did the angle sizes change? Yeah, it's still got a right angle, and these other angles would fit over here exactly. So the sizes of the angles are the same. Gentlemen, are you writing this down? I'm not doing this for my health. Did you write the size of the angles are the same?
Yes. Lengths are the same for the sides, and the angles have the same size too.
Okay. All right, so I'm going to give you a couple minutes. Feel free to talk to someone else about how you would do it, but I want a different set of transformations that would move the original triangle to what we have here for our final triangle. And then I will call on a couple of people at random. Possibly some of the same people, because that would be random. But we'll see. Because you are one of the ones I called on before. It could be you.
Why me?
Well, okay.
Hi, Sammy.
So again, check with someone, make sure that yours is good. I don't want you to be embarrassed if I call on you and it's wrong.
I rotate the triangle 90 degrees clockwise and translate 5 degrees to negative 5. So you see the possible
Johnny, have you checked yours with somebody yet? And put the book away.
When I go to the restroom?
Have you checked with someone?
Yes.
And has he checked with you?
Yes.
Okay. All right, well, let's see how it's going. Paul, you still working on yours?
Yeah.
Okay.
Get you a paper bag.
All right, Johnny, tell us what you did.
I flipped over negative 1.5.
What's negative 1.5? X is negative 1.5 or Y is negative 1.5?
Y.
Over Y equals negative 1.5. All right, hang on a second. So that would be here. So it would be like this, yes?
And then I translated to the right 5 times.
So translate right 5. So now it looks like this. Oops, they didn't make that long enough. I was like, something's not right. And then?
I rotated 90 degrees counterclockwise.
About what point? What's the coordinates?
Oh, 4 negative 3.
Yep,
Good job, Jordan.
nice job. That ends up exactly here. All right. Well, that's it for today's lesson then.